all the gold ever pulled from the earth across the entire span of human civilization. Every sovereign coin, every wedding band, every vault bar stacked beneath the streets of Zurich and London and New York would fit inside a cube roughly 22 meters on each side. That is the total. Everything. You could drop the whole of it into a few Olympic swimming pools and still have room. A single large cargo vessel could, in theory, carry every ounce of it in one crossing. And yet that same metal has started wars, built empires, and outlasted every currency system ever devised. What makes it worth that much is not its rarity alone. It is what happens to it before it ever reaches a vault. The process is older than most civilizations and more precise than most people ever consider. It begins underground, and it begins with nothing that looks remotely valuable. Gold does not occur in nature as something you could simply pick up and carry to a bank. It exists trapped inside ordinary rock, dispersed through sediment, wound through quartz veins at concentrations so low that a ton of ore might yield only a few grams of the metal. Modern mines extract this ore using controlled explosives and heavy machinery, operating at a scale that is difficult to picture from the outside. Open pit mines that stretch kilometers wide and descend hundreds of meters into the earth, moving material measured in millions of tons per year. Once the ore reaches the surface, it is fed through primary crushers that reduce it to fragments, then through grinding mills that reduce it further still, until what remains is a fine gray powder with roughly the consistency of talc. At this point, nothing about it suggests wealth. It looks like dust. The separation process that follows is where chemistry does what the eye cannot. The powdered ore is treated through one of two principal methods: cyanidation, which uses a dilute cyanide solution to dissolve the gold out of the surrounding material, drawing it selectively into the liquid and away from the waste rock; or flotation, which exploits differences in surface chemistry to cause gold-bearing particles to attach to rising air bubbles and collect at the surface of a tank. Either way, what emerges from this stage is called gold concentrate. And what happens next is the concentrate is smelted and poured into rough bars known as doré. Doré bars are typically somewhere between 60 and 90% gold. The remainder is mostly silver, along with traces of whatever other metals the original ore happened to contain. They are heavy, dull, and impure, and they are worth serious money even in this state, but they are nowhere near finished. For gold to function as a globally recognized store of value, it must meet standards set by the London Bullion Market Association, a specification known in the industry as good delivery. That means purity of at least 99.5%, and for the finest investment grade bars, 99.99%. Getting from doré to that standard requires a second, far more precise round of processing at specialist refineries. The major ones are concentrated in Switzerland, South Africa, the United Arab Emirates, and the United States. And between them, they process the overwhelming majority of the world's investment gold. There are two refining methods used at this level, and they are fundamentally different in their approach. The first is the Miller process, which is faster and well suited to producing large volumes of high-purity gold quickly. Chlorine gas is pumped directly into a crucible of molten doré. At those temperatures, the base metals and silver present in the melt react with the chlorine before the gold does, forming chloride compounds that either rise to the surface as slag or escape as vapor. The refiner watches closely. When the gold approaches around 99.5 to 99.7% purity, a distinctive purple fume, gold chloride itself, begins to appear above the melt. That is the signal to stop. The process has reached its limit and the gold is poured. For higher purity still, the Wohlwill process takes over. This is electrolysis. Slower, more precise, and capable of producing the 99.99% purity that the finest bars require. The gold from the Miller process, or sometimes directly from doré, is cast into thick slabs and suspended in a solution of gold chloride and hydrochloric acid. An electric current passes through the bath. At that point, something remarkable happens at the molecular level. Gold dissolves from the anode and deposits, atom by atom, onto the cathode. And because gold responds to the current at a different rate than any impurity present, what builds up on the cathode is essentially pure. When enough has accumulated, the cathode is removed, washed, dried, and melted. What pours out is as close to elemental gold as industrial refining can achieve. Now the metal has to take on the form recognized in every vault and trading room on Earth. For cast bars, the kind most people picture when they think of bullion, the molten gold is poured directly into preheated molds that have been set on a precision scale. The moment the target weight registers, pouring stops. The mold is then tilted, and the bar drops into a water bath for rapid cooling, a technique called quenching. The result has a slightly rough surface, gently rounded edges, and an appearance that is honestly utilitarian. No two cast bars are identical. Each one carries the faint marks of the pour, the cooling, the particular moment it was made. In a world of engineered uniformity, they carry something almost handmade about them. Minted bars follow a more demanding path. The refined gold is pressed hydraulically into flat strips, which are then passed repeatedly through rolling mills until they approach the required thickness. Partway through, the strips may need to be annealed, heated in a furnace, to relieve the internal stress that repeated rolling creates, restoring the softness needed to continue working the metal. Once the strip reaches exact specification, individual blanks are punched from it, weighed, tested, polished, and cleaned. They then pass through a coining press and are struck under high pressure against a hardened die, exactly as a coin is struck, transferring a mirror-finished design into the surface of the metal with a single, precise blow. Any blank that fails inspection at this stage goes back into the melt. Nothing leaves the process that has not passed. What every bar receives before it leaves the refinery, regardless of which method produced it, is a set of permanent marks: the refiner's hallmark, the purity to 4 decimal places, and a unique serial number. Some also carry an assayer's stamp, an independent third-party certification that confirms the bar's weight and purity without relying solely on the refiner's own word. That stamp is what gives a bar instant credibility and immediate liquidity in any market in the world. Without it, a gold bar is just a heavy object. With it, it becomes a universally accepted instrument of value. From the refinery, the bars move into a logistics chain that treats every gram as a potential target. Armored transport, documented chain of custody, multiple verification points at each transfer. The paperwork that follows a gold bar from refinery to vault is meticulous precisely because the gap between a bar with a clean, unbroken record and one without is the difference between full market value and a very difficult conversation. A rock blasted from a hillside, ground to powder, dissolved in chemical solution, electrolytically deposited atom by atom, poured into a mold, struck with a die, and assigned a number. That is the complete distance between the ground and the most universally trusted store of wealth in human history. There is nothing mystical in it, nothing automatic. Every gram of value that sits in every vault on Earth was built by that process, step by step, exactly as you have just seen it. If you found that worth understanding, the next video is already waiting.